Hello, honors algebra students. Today we are going to learn about arithmetic and geometric sequences. And the cool thing is you already kind of know this stuff. We've been doing with functions. The arithmetic sequence is something that can apply when our function is going to be linear. So if you know it's going to make a linear function, then it's going to be an arithmetic sequence. A geometric sequence is going to apply when it's exponential. Okay, exponential. Now, if the sequence is not linear or exponential, then it won't apply to either of these. So if you did a quadratic or a cubic, for example, it won't work. Arithmetic simply means that there's a common difference all the way through, just like the linear function meant that. Geometric means there's a common ratio, meaning it's being multiplied by some number. Sometimes it's a fraction, sometimes it's a whole number. We almost always use a fraction to denote it. All right, now there's some funny equations down here. I want you to understand what they mean, okay? A is a number. A is an unknown number, okay? A sub 1 is just the first number of the arithmetic sequence, okay, or of the geometric sequence. That's all that A sub 1 is, it's first. So in this green sequence down here, which will be arithmetic, we'll explore it in a minute, A sub 1 is 7. 10 is A sub 2. 13 is A sub 3, etc. See how that works? The sub, it's not an exponent. It just means the first A, the second A, the third A, etc. Okay, now, A sub n is just whatever A we're going to. Like if I asked you to find the 79th term in the sequence, it would be A79. So this is just the term we're ever going to. N is the number we're going to. All right. Oh, I think I have a mistake here. Yeah, I do. Sorry. Hopefully you didn't. You can correct that. You still have time. That should just be an n minus 1 there. Sorry about that. Okay, D is the common difference. The common difference, whether it's positive or negative. So if it's plus 3, like on this one here, it's plus 3, then D would be 3. If it's minus 7, then D would be negative 7. N minus 1 is just one less than the number we're counting to. That's all, the number we're counting to. Okay, I'm going to explain the geometric later. Let's go ahead and see how this works. So let's come down to this 7, 10, 13, 16, 19 sequence of numbers or series of numbers. All right, so we want to know the 30th term. So in other words, we want to know A sub 30. Okay, I'm going to find A sub 30 by taking the first term, A sub 1, and I'm going to add the common difference times 1 less than 30. That's what the n minus 1 is. So let me fill in everything I can. A sub 30 is going to equal 7 because it's the first term, plus the common difference. It looks like it's going up plus 3 again, plus 3 again. Right, so plus 3 times the quantity of 30 minus 1. 30 minus 1, which of course is 29. Now, following the order of operations, oops, sorry, I went too far there. A sub 30 is going to equal 7 plus 3 times 29. Well, 3 times 30 would be 90, so I think it's going to be 87. And then A sub 30 is going to equal 94. Now, before we knew about this arithmetic sequence, we would have had to take the numbers, where are they going? 7, 10, 13, 16, 19, okay? And then we would make our little table, right? Right? And it's still a good thing to do. I mean, if they're asking us to identify a function, well, we would still do this. There's nothing wrong with doing this. This arithmetic sequence for a linear function is a little bit easier. It's quicker, certainly. All right, and so I'm going to go to the nth term, and it's plus 3 every time, right? Plus 3, plus 3, plus 3. So I'm going to have a 3n. And I do my comparison line, and I get what? 3, 6, 9, 12, 15. And I notice the red ones, my comparison line, are all 4 short of the f of x line. So my nth term is going to be 3n plus 4. Therefore, my function would be f of x is going to equal 3x plus 4. Why am I doing all this? Well, I want to find the 30th term, so that'll be f of 30. That's going to be 3 times 30 plus 4, which of course is going to be 90 plus 4, or 94. So you see, I get the same exact answer. This way is a little bit quicker. Actually, it's a lot quicker, to tell you the truth. It doesn't work for a quadratic or, say, a cubic sequence, but it works really well for an arithmetic sequence, or a linear sequence, excuse me, which is, of course, arithmetic. All right, so let's go forward here. And here's another arithmetic sequence. If you'd like to pause the video, see if you can do it on your own. Remember, the formula is a sub n is equal to a sub 1 plus d times the quantity of n minus 1. Write that down a few times, memorize it. It'll be so easy to do. All right, here comes my solution. If you haven't tried yet, pause the video. So on the 80th term, that's what a sub n is, the 80th term, I need the first term, which in this case is 12. D looks like it's minus 4, right? It's going down 4 every time. And n minus 1 is going to be 79. 80 minus 1. So that's going to equal 12. Let's see, 4 times 8 is 320. This is 1 less 4, so I think it's going to be a negative 316. I think I'm going to get a 304, a negative 304. The 80th term will be negative 304. That should work. I mean, I could check real quick doing my f of x way. Let me just kind of do it in my head here so I don't take as long. I know I'm going to need a negative 4x. It's going down 4 every time. And I think I'm adding 16 every time. And so if I put 80 in here, into f of x, into the function, I get negative 4 times 80 plus 16. And I'm going to get a negative 320 plus 16. And that equals negative 304. Now, some of you are wondering which way do you have to do it. It depends on the way the question is asked. If it just says find the 80th term, you can do it the way we've been doing it. But if it says something about an arithmetic sequence, then you have to do it using that formula. All right, let's go ahead and talk about the geometric sequence. The geometric sequence is very, very similar. Again, this is just the first term, first number or first term in the sequence. Okay, a sub n is the number we're going to, right? Just like in the other one. R is that common ratio. Remember, these are going to be like exponential ones. That's where the differences are being multiplied, times 2, maybe times a fourth, things like that. And that's to the power of n minus 1. Just like that was times n minus 1, this is to the power of n minus 1. So let's see how this works on this black one. Okay, I want to find the 20th term of this sequence of numbers. Well, it looks like I'm multiplying by 2, doesn't it? Every single time? That's a hint that it's exponential. Okay, so I'm going to find a sub 20, the 20th term, and I'm going to take the first term, which is 2, and I'm going to multiply it by r. Well, r is the times 2. And I'm going to raise r to a power. What power am I going to raise it to? The 20 minus 1. In other words, this will be 2 times 2 to the 19th. Okay? And when you evaluate that, you get a very large number. Hold on a second here. Where'd my calculator go? There it is. So I'm going to do 2 times 2 raised to the 19th. By the way, wouldn't 2 times 2 to the 19th be the same as 2 to the 20th? Wouldn't it? Let's see, what is that? 1,048,576. Uh-oh. Hold on, I'm holding my airliner pen upside down. It's not going to work that way. All right, so we got 1,048,576. And there you go. All right, now back to what I was just saying. Wouldn't 2 to the 1st times 2 to the 19th be the same as 2 to the 20th, right? Remember we learned first semester, x to the 5th times x to the 7th would equal x to the 12th, right? the bases are the same, you could just add the exponent. So if you wanted to on your calculator, you could just do 2 to the 20th, and you're going to get the same number. Now, I want to convince you that the 1,048,576 number is the same. So I'm going to do it manually. Now, I'm not going to start with 2 to the first because I know I start with 32. I've got 32, which is 2 to the fifth. So where'd my calculator go? I think it's hiding. There it is. So I'm going to go 2 to the fifth. Okay, it's 32. And I'm going to multiply it by 2. And I'm going to multiply that. So I got to count 6, 7. Just keep multiplying by 2. And there's 8. And there's 9. And there's 10. And there's 11. And there's 12. And there's 13. And there's 14. And 15. And then 16. 17, 18, 19, and then finally the 20th term. And there it is. I got the same number that I got before. Okay, you don't have to do that all the time. I just wanted to show you that it is going to be the same thing. All right, so let's go. There's one more example I have ready for you. What is the 8th term? And I did a small one so it'd be easier for you to check. A lot of you could just figure out the 8th one, but I'm giving you a small ones to be able to check your answers and have it make sense. So please don't just figure it out. Please use the geometric sequence. So I'm going to need a sub 8. That's going to need to equal a sub 1 times the common ratio, and the ratio will be to the 8 minus 1 power. Well, I know a sub 8, I know a sub 1, well, I'm looking for a sub 8. A sub 1 is 54. I don't know this common ratio. I got to figure that part out. Whatever it is, I'm going to raise to the 7th power. Well, how do I turn 54 into 18? Well, you're probably going to say I divide by 3. I divide by 3, and I divide by 3. This formula is not set up for division. So instead of doing divided by 3, I'm going to think, what could I multiply it by? And hopefully by now you're building enough number sense that you can see that dividing by 3 is the same as multiplying by 1/3, right? 1/3. So I'm going to multiply by 1/3. That's what R is going to be. If you don't believe me, take your calculator, multiply 6 times 1/3. You will get 2. Remember back first quarter when I was stressing so much, understanding how Wonder Woman did her thing? Look at that, 2. So 1/3 is the common ratio. So I don't know 3 to the 7th power, 1/3 to the 7th power off the top of my head, but I can go to my calculator here, and let's see here. So I'm going to do 54 times, and if you want to know how to put it in, here's how you do it. 1/3, and then I'm going to raise that to the 7th power. Now, this calculator knows the order of operations, so it'll do 1/3 to the 7th first, and then multiply by 54. Okay, order of operations, exponents before multiplication. All right, and there you go. Now this is not a really good answer for a geometric series problem. We like fractions. So I'm going to go math. Number 1 is frac. I have a choice. I can hit enter or just hit the 1, and then it'll turn it into a fraction, and I'll get 2/81. So I'll get 2/81 here. So a to the 8, a sub 8, excuse me, is going to be 2/81. I'm not sure why that won't go away. There we go. Now, let me just figure it out kind of manually, just to prove to you you get the same thing. So I'm going to 54, that would be a sub 1, and then a sub 2 is 18, divide by 3. Now I'm at a sub 3, and then a sub 4 is there, and then a sub 5, 2 divided by 3 is 2/3, right? Then a sub 6 will be 2/9. A sub 7 will be 2/27, right? And then a sub 8 is 2/81, and that's what I was supposed to get. All right, that's it for the video. Arithmetic and geometric sequences. Make sure you learn them. We'll get some practice with this tomorrow. Mr. Lawrence signing off. Have a good night, everybody.